Loom Crafts is one of the leading company in India, manufacturing and building light-gauge framing system prefab structures. Loom Crafts prefab buildings are strong, earthquake-resistant, with luxurious finishes, faster in construction, suitable especially for hill areas. Ideal for residential homes, multi-story apartments, commercial buildings, hospitals, hotel and resorts, colleges and institutions. Loom Crafts introduces prefab, modular homes, high-tech buildings and luxurious villas. Loom Crafts makes prefab buildings look just like the traditional civil buildings, with luxurious finishes. The buildings made by Loom Crafts does not give the look of prefab structures. We have developed a different technology for construction industry. We custom design your prefab homes. We discuss, design as per your choice, and then build. Loom Crafts welcomes you to view this presentation on prefab buildings. The Loom Crafts difference. Building your dream home is a major investment, and today, more than ever, not all homes are created equal. As you look around, you'll find wide disparities in the quality of design and building materials, even among high-end homes. That's why it's so essential to know what you're getting for your money, and why so many people who could choose to build any new home, choose Loom Crafts. We're proud to share with you the expertise and legendary quality behind our long-standing reputation for exceptional materials, inspired design, structural integrity, energy efficiency, low maintenance, and lasting value on a wide range of budgets. Take a closer look at the Loom Crafts difference, and discover what a difference it can make to you. Planning your new home should be a pleasure, and at Loom Crafts, it is. You'll find the perfect balance of personal choice and expert support every step of the way. You can have as little or as much involvement in the planning process as you wish, and at any point, Loom Crafts is ready, willing, and uniquely able to help you transform your personal wants and needs into floor plans and elevations. Designed to production in no time. The heart of the Loom Crafts system, state-of-the-art, industry-leading design software, used to interpret the architectural designs into steel panel designs. Powerful and flexible, software is capable of designing virtually any element: walls, roof, ceilings, floors, and even items such as gable panels, overhang outlookers, soffit panels and more into panel assemblies, ready to run on the CNC roll forming machine. Loom Crafts has designing collaboration with Prescient of USA, leading company of the world, for designing light-gauge steel frame buildings.
Structural system that sets new standards in multifamily residential construction. Thanks to our unique engineering approach, the Prescient system can support up to 12 stories without need for structural concrete or hot-rolled steel. Standardization is the key to this innovative panelized structural system. Prescient's library of cold-formed steel components includes just 19 panels, 1 truss configuration, and 1 column profile. As a result, structural layout is more predictable and uniform, without limiting interior layout flexibility or exterior architectural expression. And standardization makes both design and manufacturing of our Prescient panelized structure more efficient, while significantly reducing your material costs and installation time. Here's a bearing wall structural system. We employ only 3 elements: truss, column, and panel to resolve any building. Our uniquely engineered panels are designed to transfer vertical and lateral loads at the floor and roof trusses to a redundant column system, rather than from panel to panel vertically. This allows us to employ light gauge materials and uniform spacing of framing members from the top floor to the bottom floor. This also allows Prescient to limit the number of standardized elements within the structure, and a limited number of standardized elements enables our software to resolve and engineer the building. Your structure is manufactured to very tight tolerances in our factory and built to that same level of precision on your site. Prescient's Autodesk Revit-based application automatically creates a 3D replica or BIM model of the structure. The model is not merely an approximation of the structure, it's an exact replica of how the building will exist in the built environment, fully engineered to a specification level of detail. And having a virtual 3D match of the structure in advance enables you to get a jump on clash detection, makes MEP engineering more efficient and predictable, and saves money by finding problems in the office and not in the field. It's a genuine breakthrough in multi-unit residential construction, a light gauge, steel structure that's designed and ready in days rather than weeks.
Sometimes a standard will stand the test of time. And sometimes it's time for a change. Steel. The new shift in light gauge steel framing. To the world of difference. Welcome to the world of steel. Why steel? Well, here's why. No splitting, no cracking, no warping, no rotting. What else? Non-combustible, mold-resistant, dimensionally stable, termite-proof. It also has the highest strength-to-weight ratio of any building material. And guess what? 20 years later, it's still steel. Steel is lighter than other framing materials. Build with steel and get consistent quality. Straight wall, square corner, smaller punch list, stronger connections, no nails, fewer callbacks, fewer hassles, less scrap, less waste. 2% in fact, that's it. 2% waste when building with steel materials. Compare that with the 20% scrap and waste when building using timber. Build more. High strength results in a safer structure. How does this benefit the homeowner? Lower maintenance and the highest protection against foundation problems, environmental deterioration, and fire damage. Steel doesn't grow on trees. It comes mainly from recycled steel. It's the most recycled material in the world. A 200 square metre home can be built with steel made from just 6 recycled cars. This is steel. It's here to stay. Build with it. Build with it.
Our structure frames leverages mostly cold-formed, high-tensile strength, light-gauge galvanized steel. This sustainable material is cut to tolerances of 1/8 of an inch and pre-drilled for rapid on-site assembly. Additionally, the steel is galvanized with a G60 or G90 rating, ensuring it is resistant to rust and corrosion. Compared to traditional construction, steel is an engineered material with precisely known and calculated load-bearing capacities. As a result, a steel structure can be designed more accurately and with less waste than a traditional structure. Steel structures have been proved to be earthquake resistant. Steel buildings do not collapse as the normal civil buildings. Homes built with steel look better, perform better, and provide a safer environment for inhabitants. About steel framing, there are many reasons why steel framing has come to the forefront as one of the best and most feasible alternative building materials for residential and commercial construction. Steel is a superior construction material with many benefits, as mentioned here. Height advantages. Fast facts. Steel does not change size or shape with changes in moisture content, which helps prevent cracks in finishes such as drywall and stucco. When they get wet, both wood and brick will swell. When they dry out and cure, concrete and concrete block will shrink and form shrinkage cracks. Steel is isotropic, meaning it has the same dimensional properties in all directions. Since there is no grain, the strength of steel is the same up and down, side to side, and in all loading directions. Steel does not warp, shrink, or crack in normal loading and framing applications. Steel is ductile, and will bend and stretch when overloaded, rather than cracking or breaking like unreinforced concrete or masonry. Steel is 100% non-combustible. Therefore, height and area restrictions on combustible materials do not apply to cold-formed steel. Steel is ductile, and will bend and stretch when overloaded, rather than cracking or breaking like unreinforced concrete or masonry. Fire resistance. Steel is a non-combustible, fire-resistant material and will not feed a fire. On average, wood structural members or framing rank third as the first ignited material in home fires, according to the National Fire Protection Association. Building with steel can reduce construction insurance as well as homeowners' premiums. Performance of steel-framed houses during an earthquake. Earthquakes are one of the most destructive forces in nature. In recorded history, single seismic events have altered the course of major rivers, erased landmasses from the map, and devastated man-made structures within a considerable distance of the earthquake epicenter. Frequently, earthquakes also produce additional hazards, such as tidal, tsunami, and fire, caused by damage to the infrastructure of a populated area. The inevitable consequence of any seismic event is the loss of life. Improvements to design and construction methods in the world over the past 50 years have helped make the modern home a safer habitat during an earthquake. One of them, the use of light steel gauge framing, offers very real advantages over traditional wood framing or civil building should an earthquake strike. It is a known fact that earthquakes do not kill people, buildings do. As mentioned earlier, earthquakes do not kill people, buildings do. 90% of the casualties in an earthquake are due to the collapsing of the buildings. Here, we show you some of the earthquake testing of light gauge framing buildings done by various organizations in the world. It is a well-known fact, the lighter the buildings, it is a safer building during earthquakes.
More than 1 million people have died in earthquakes in the last 2 decades. Seismic rumbling between the Earth's tectonic plates puts some of the world's most densely populated countries at particular risk. These plate boundaries are most apparent around the Pacific Rim. Frequent earthquakes have led to the region's nickname, the Ring of Fire. Yet for the most part, earthquakes themselves don't pose the greatest risk. Collapsing buildings do. While buildings are generally designed to withstand vertical loads, the weight of their contents and inhabitants, they've not traditionally been built to withstand the side-to-side swaying that a tremor can bring. It's possible to design buildings so they're more resilient to earthquakes, keeping them light and flexible so that they can absorb and distribute the energy of their movement. Start with the roof, which should be the structure's lightest part. In the 1995 Hanshin earthquake in Japan, and the recent quakes in Nepal, much of the damage was among top-heavy tiled roofs. In 2008, a magnitude 8 quake in the Chinese province of Sichuan took more than 80,000 lives, and engineers found tile-clad buildings largely to blame. Using materials that can bend without breaking helps make buildings more shock-absorbent. This building has steel embedded in its frame. It's being put through its paces on what is known as a shake table at the Hyogo Earthquake Engineering Research Center in Japan. Tests like these show how a building's frame is also important. Light walls and partitions and thin concrete floors can help. So can what are called shear walls, a system of panels and braces that effectively channel a side-to-side force downward into the building's foundations. The giant concrete columns at the center of modern skyscrapers do exactly that. There's also a bit of simple physics known to the architects of ancient Japanese pagodas. These were built with a giant central pole called a shinbashira, which acted as a tremendously heavy pendulum. Seismic shuffling of the pagoda's main structure transfers into the gentle swaying of the shinbashira. Since it was built in the early 7th century, the enormous Horyuji temple in Japan has survived dozens of big quakes. Modern builders have taken note. Taiwan's Taipei 101 and the Citicorp Center in New York use hundreds of tons of concrete or steel to do the same job. All this has the potential to make newer buildings safer. But as much of the infrastructure damage in Nepal has shown, it's also very important to apply this hard-won engineering knowledge and retrofit older buildings as well.
The Economist.
What happens to a house during an earthquake? The earthquake seismic forces that can destroy a house are produced by strong and erratic side-to-side and up and down movements in the ground. Structural damage is typically caused by inertia, or the reluctance of the upper portions of a structure to begin moving once the ground has shifted, and then conversely, to stop moving once the structure has begun moving. When the earth shifts sideways, the effect of inertia on a house is similar to that experienced by players in a game of Crack the Whip. If the movement is vertical, inertia causes the structure to be compressed as the earth rises and telescoped as the ground stops moving. Homes are designed to resist the stresses of inertia by absorbing the energy that is produced by earthquakes. This is commonly accomplished by allowing the structure to flex with the ground movement in varying degrees, depending upon the material used to build the house, design of the structure, quality of construction, level of engineering, and the applicable building code. Engineering the house for earthquakes. Houses framed with either wood or steel rely on the same basic design concept. Induced lateral forces, such as those produced during an earthquake, subject the structure to sliding and racking. To control this motion, the roof and floors must be tied to the walls, all the way down to the foundation. In addition, the racking must be limited to tolerable levels. The roof and floor between stiff walls must be designed to limit motion and transfer loads to the walls, and ultimately, the foundation. Since the lateral forces are primarily generated at the floor and roof levels, walls tend to uplift and overturn. This is controlled by tying the walls together to reduce uplift forces, and ultimately fastening the walls to the foundation. Light gauge steel construction. Most regard light gauge steel framing as a modern concept, although it has been used in both residential and commercial construction for many decades. So, while steel framing has recently become a viable contender in the home building industry, it has a reliable track record, over an extended period, for consistent performance as a structural material. There is no difference between the appearance of a home framed with light gauge steel and one framed with wood or civil construction. Rather, the most significant difference between a steel framed house and another framed with wood or concrete is determined by how well the framing material can provide long-term, consistent performance. For example, sagging roof lines typically found in an older wood-framed home are not evidenced in steel-framed homes. Light gauge frame building, the only solution to earthquake-resistant buildings. After experience and long research, today the designers and architects worldwide have accepted light gauge steel buildings as safer buildings compared to other buildings. Conclusions. Structural steel use around the world is between 30% and 55%. Unfortunately, in India and other Asian countries, this ratio is below 5%. Steel sat on the agenda widely after several earthquakes in the region in previous years, so the existing steel manufacturers started to improve their technology, and many new entrepreneurs became interested in the sector. By using structural steel in the load-bearing system, various geometrical forms can be designed, which is not possible with other materials. It is a well-known fact, both from the steel's inherent features and from the experience, that steel is a suitable material in earthquake regions. This fact should be disseminated by designers and operators to all. We have explained and shown many facts of the light gauge frame system buildings. These are the safest buildings in earthquake-prone areas. Loom Crafts. Motive is to provide better technology for building safer homes. Now we show you some other features of the light gauge frame buildings. Termites cause more damage than fire, floods, and storms combined. Cold-formed steel is one of the recognized methods for compliance with the termite-resistant construction requirements of the International Residential Code. Choose light gauge frame system and do away with the worries about exclusions in the fine print of warranties for treated wood or the presence of chemical treatments in your building or soil. Light gauge frame system is inorganic and does not provide a food source for termites. There is no need for annual termite treatments with steel. Light gauge frame system provides a healthy building with no off-gassing from chemical termite treatments or pressure-treated lumber. Termite damage is rarely covered by insurance. Build it right and avoid costly problems later. Light gauge frame buildings are green buildings. External and internal wall coverings. Cement fiber wall boards are synonymous with quick, hassle-free wall solutions. They are made using the revolutionary HPSC technology, which makes them completely moisture, termite and fire resistant. Cement fiber wall boards, in combination with different substrate framework like timber, steel and aluminum, offer unique advanced, drywall constructions, which leverage space utilization to the maximum, with substantial savings on time. Architects prefer to use them, as they offer flexibility when it comes to changing designs, besides being durable and maintenance-free. Loom Crafts has collaborated with Pioneer, leading company of the world, for infilling of the light gauge frame walls. The infill provides good insulation against the harsh weather conditions, and also safety for the buildings. As you must be wondering, that someone could break the cement fiber board and enter your house. Just wait till you see the next presentation.
This construction solution is an innovative way of developing building and construction technology that can significantly shorten construction time. Building a finished basement with an area of 250 square meters can be erected in just 30 days. A metal frame composed of bent galvanized profile, which is mounted on a prepared foundation, is the basics of pioneer construction technology. Heavy combined fiber cement panel serves as permanent cast framework inside and outside of the wall. Arrangement of service lines is put between the panels. The panels are fixed to the steel frame using screws or special latches. The joints are sealed with standard adhesives. Wall thickness and panel dimensions depend on the general technical requirements of the thermal building insulation, acoustic isolation, and strength. Dry mixture of Pioneer compound is mixed with water in a special hydraulic mixer that does not require connection to an electric supply, is then poured between the installed panels, completely filling the space inside. Within 40 minutes, the mix increases in volume from 2 to 3-fold and turns into a homogeneous monolithic structure. An important advantage of Pioneer technology is that it allows for construction of buildings in all regions, including those remote from power supply.
Now, we show you various roof options available in our prefab buildings. The first option is to have PVDF coated sheets on the roof. Fiberglass asphalt shingles. Asphalt shingles come in two types, organic and fiberglass. Organic shingles are based on paper, saturated with asphalt to make it waterproof, with coatings of adhesive salt and ceramic granules embedded on top. Fiberglass shingles are made with a base layer of glass fiber reinforcing mat. This mat is coated with asphalt, which contains mineral fillers, and makes the shingle waterproof. Stone-coated metal roof tiles. It is unbelievably lightweight roofing system. These are designed and manufactured to withstand all kinds of severe weather, such as extremely hot and cold weather, strong wind, and heavy rain. The core strength is galvanized steel. Galvanized steel has long-term corrosion resistance. On both sides of this core strength, additional coating systems, applied respectively, for enhanced durability. The stone chips are then embedded to provide enhanced strength and beauty. Loom Crafts makes flat roof prefab buildings. There are many types of finishes which can be done on the flat roofs. The most common is the vitrified tiles, marble, natural stones. Wall and roof insulation. Wherever cement, concrete and fill is not done, we provide glass wool insulation in the walls and the roof to protect the building from harsh hot and cold weathers. We use the best brands available in the market. Loom Crafts has developed the technology for plaster of the external and internal walls of the prefab buildings. Ready premixed plaster finish. Premixed fiber reinforced, ready-to-use cement-based mortar for external as well as internal plaster, reinforced with cement-compatible polypropylene fibers to reduce drying shrinkage and other cracks, ensures waterproof, reduced crack-free plaster of consistent quality, enhanced labor productivity, and less rebound wastage during plastering, reduces the cost. Loom Crafts offers various choice of exterior finishes. Please download Loom Crafts catalogs for details. Artificial stone veneer for exterior wall, made by Loom Crafts. Slip brick and stone, exterior and interior wall claddings, made by Loom Crafts. Stone veneers for exterior wall finish, made by Loom Crafts. Choice of interior finishes. The interiors can be finished as per the client's choice. We can finish the walls with gypsum, POP, which can further be painted or can be decorated with wallpapers. The internal walls can also be finished with natural wood planks, giving the interiors a natural feel. There are various choices for internal finishes. Please study our catalogs. Textured finish wall. Natural wood finish wall. Wallpaper finish wall. Stone finish wall. Choice of ceiling finishes. Wooden ceiling finish. POP painted ceiling finish with cove. Grid ceiling cement fiber board. There are various choices for ceiling finish. Any type of finish can be done in our structures. Choice of floorings. Vitrified tile floors. Marble floors. Laminated wooden floors. Various choices are available for toilets and baths. Various choices are available for toilets and baths. Various choices are available for kitchens. Various choices are available for kitchens. Top 10 things you should look for when you build. A reliable company. Solid construction. Warmth. Customized design. Innovative. Eco-friendly. Maximum living space. Indoor and outdoor flow. Low maintenance. Value for money. You can trust Loom Crafts. types of prefab buildings we offer: residential homes, villas, commercial buildings, schools and colleges, institutional buildings, hotels and resorts. Thanks for viewing the presentation. We are here to answer all your queries and answers.